Now, underneath the epidermis and the dermis, we have the subcutaneous layer, okay, or the sub-Q layer, or the hypodermis, hypo meaning underneath the dermis. These are all different words that have been used and can be used to describe the subcutaneous layer or the hypodermis, okay? Now, one thing to keep in mind here is this is technically not part of the integumentary system. This is basically just a layer of connection or a connection point between the dermis and then underlying tissues underneath, whether that's muscle, fascias, or bone, or whatever that may be. But because of its proximity to the other stuff, we're just going to kind of talk about it now. Now, importantly here, the hypodermis does actually have several important features that does actually lend itself with some of the other features that are taking place in, say, the dermis or even the epidermis. Uh, First off, we do have blood vessels running through it. So, and this is adipose connective tissue. We are also areolar connective tissue. These are both very, very vascular tissues. Areolar connective tissue, remember, was also used up here in these dermal papillae, where we have lots of blood vessels so that we can get lots of nutrients up here to the epidermis. So we have lots and lots and lots of blood vessels moving through here, lots of blood. Okay. Now, that makes this area very, very important, especially in things like, say, temperature regulation. Okay. So temperature regulation is very, very important. Okay. Having lots of blood vessels here means we can use it for temperature regulation in a lot of ways. So we can regulate body temperature, remember, based off of either vasoconstriction or vasodilation. If we constrict blood vessel flow, that means, or constrict blood vessels, that means we have decreased blood flow through them, which is actually going to cause temperatures to go down. Because remember, blood is warm. Okay. At least temperature in this area to go down while also maintaining warmer temperatures kind of in the core areas. Okay. The opposite is also true. If we open up the blood vessels, we can get more blood running through these areas. You would need to do this if you were, say, trying to cool off your skin. So you would actually close off blood vessels up here to get blood away from the surface of the skin. This is going to make you appear pale and stuff like that, but this happens when it's cold. So you don't want a whole bunch of warm blood up next here to all of the cold environment outside. So we close off those blood vessels so not as much blood gets cooled by the outside environment so the inner part can stay nice and warm. Now we can do all that same stuff down here in the hypodermis, but we also have all of this fat and stuff, which is helping separate the skin from the underlying tissue. So we're helping insulate the underlying tissues and keeping them away from the cooler environment outside. So the hypodermis is actually going to be very important in helping us insulate those underlying tissues so that our underlying tissues do not need to get as cold. Okay, so basically it's like putting on a little bit of a jacket. Okay, now the size of that jacket is going to vary depending on different parts of the body. Okay. In places like your arms and your face, it tends to be quite a lot less than it is in places like your midsection, your buttocks, or anything like that. Now, this is also, though, going to be regulated on lots of different things. One of the chief of these is actually going to be our sex hormones. Okay. Higher levels of testosterone is going to mean that we're going to store some of that fat in places like our upper arms, the front of our belly, and in our buttocks. Whereas instead, if you have lots of, say, estrogen and progesterone, this is actually going to cause that fat to primarily be a little bit thicker, just kind of all around, so all throughout the body, but especially in places like the breast tissue, so kind of the upper chest region, and then also into the buttocks and in the thighs. Okay, so these sex hormones are going to regulate the proportions of the layer of this hypodermal fat. Okay. Now, it's also very, very important in protection because, once again, by having a barrier, or not even a barrier, just a layer in between, say, the skin and the underlying tissues, if this layer is thicker, that actually just means that there's a bigger layer of protection before you actually get to underlying tissues. So much so that, say, like the gladiators back in Roman times and stuff like that, would actually put on fairly large layers of fat, especially around their midsections and stuff like that. They ate a whole bunch of barley. People call them barley crunchers, so that they could put on a whole bunch of fat, so that cuts and abrasions and things like that, like, so if they didn't quite walk a sword correctly, that instead of getting to the meat underneath very, very easily, instead it would have to go through a thicker layer of tissue, so skin, and then finally a thicker layer of fat before it actually had a chance of getting to the muscle or something like that which could affect their ability to survive the fight. So people like to think that everybody was all like ripped like Russell Crowe was back in those days. But that's not quite the case. In fact, they look more like Russell Crowe does now than they did the way Russell Crowe looked in that movie. Okay. Now we also use this stuff, of course, for energy storage because it is a lot of fat. Fat is in large part energy storage, and we can actually regulate how much body fat we're going to have based off of kind of the way the things that we're eating and the timings and stuff like that when we are eating them. And all of this is going to be regulated by insulin in large part. And we will talk about that next semester once we actually talk about insulin when we get to the endocrine chapter. Now, all these blood vessels and stuff moving through the skin or moving through the hypodermis are also a very important place for, or also cause us to use this as one of our primary drug injection sites. So you take a needle and you inject it not into the epidermis, not into the dermis, but actually into the hypodermis because of all those blood vessels. All of those blood vessels are going to cause rapid uptake of those drugs, which means we get rapid uptake into the blood so we can send those drugs on where they need to go very, very quickly. So that just makes things a lot easier for us. So those are some of the functions and features of our hypodermis. So if you have any questions or anything like that, please just let me know. Thanks. Bye.